For 5.1a, we're going to talk about some of the basic exponent properties and kind of review them to start with here. The first property that we have is the zero exponent property, which says for any non-zero number, so we'll just call that a, if we take it to a power that is 0, it's going to be equal to 1. So, for example, we have 4 to the 0 power is equal to 1. Okay? And this is true for any number that where a is not 0. Okay? So we could take other examples. We could take 7 to the 0 power, and it would be equal to 1. We could take a larger number, right? We could take 2,381,542. If we take it to the 0 power, it's still just equal to 1. Okay? So no matter what number it is, as long as it's not 0, it's going to be equal to 1 if it's to the 0 power. Okay? The next one we have is the negative exponent property. Okay? So for any integer n and any non-zero number a, if we take a to the negative n power, it's going to be equal to 1 over a to the n. So what that's saying is, if we have some integer, okay, so for example, we could have 3. If I take it to a negative power, what's going to happen is it's going to become 1 over 3 to that positive power. It's going to turn the power positive and makes it to a fraction. So it takes it from this kind of regular integer into a fraction. Alternatively, if we start with a fraction, so 1 over 4 to the negative 2 power, it's going to then become 4 squared. So it's going to make the exponent positive, and it's going to go from the bottom of our fraction to the top. So it's either going to become a fraction or the opposite, goes from a fraction to just a regular integer. Okay, that's essentially a negative property. Some more examples could be if I take 4 to the negative 5th power, that's the same thing as 1 over 4 to the positive 5th power. Or I could have something like 1 over 7 to the negative 3rd power is the same thing as just 7 to the 3rd, the positive 3rd power. Okay, so that's just some examples of our negative exponent property. The next one that we have is product of powers property. Okay, so if I've got two numbers that have the same base, right? So I've got, for example, here we've got two 4s, so they're both the same base number. They're both 4, and they both have a power. Okay, if I multiply these two together, what's really going to happen is I'm going to add the exponents together. So in this case, right, I had 4 to the 6 times 4 to the 3rd is the same thing as 4 to the 6 plus 3, which is equal to 4 to the 9th. Another example might be if I had 2 to the 5th times 2 to the 7th. Okay, that's the same thing as 2 to the 5 plus 7, which is the same thing as 2 to the 12th. Okay, I just added them together. So we multiply, we add. Okay, alternatively, right, we can look at quotient of powers property. So instead of multiplying, now we're going to be dividing two numbers that have the same base number with an exponent. Okay, so just as multiplying is the opposite of division, subtraction will, so since we were multiplying, the opposite would be dividing. So now instead of adding, we're going to do the opposite of that. We're going to subtract. So in this example, we had 4 to the 6 divided by 4 to the 3rd, which is the same thing really as 4 to the 6 minus 3 power, or just 4 to the 3rd. Another example that we could try is we could take 5 to the 6, no, let's take a different one. 5 to the 9th power divided by 5 squared. This is the same thing really as 5 to the 9 minus 2 power, or 5 to the 7th. Okay. Our last three that we have on here, so power of a power. Okay. Don't get this one confused with the product of powers. Okay. What's happening here is we have some integer, right? So we have, for example, 4 to the 6. Okay. We're taking 4 to the 6, and we're taking this whole thing and we're taking it to a new power, to the power of 3. So what's going to happen here is when we have a power to a power, we're going to multiply them. So 4 to the 6 to the third power is the same thing as 4 to the 6 times 3 power, or 4 to the 18th. Another example might be if I had, we'll say, 2 squared to the 5th power. This is really the same thing as 2 to the 2 times 5 power, or 2 to the 10th. Okay. So power to a power, we multiply. Power of a product property. So to find the power of a product, remember, a product is the answer of a multiplication problem. Okay. We can find the power of each factor and then multiply them together. So I have 3 times 2 to the 5th power. Okay. The quantity 3 times 2 to the 5th. It is also the same as 3 to the 5th times 2 to the 5th. Another example for you might be if let's say I had 6 times 4, right? And I take that to the power of 3. This is really the same thing as 6 cubed times 4 cubed. Okay, so it's just another way that we can rewrite that. Okay. Alternatively, we can do the same kind of thing if we have a power of a quotient. So instead of multiplying, now we're going to be dividing it. Okay. So we have, for this example, we have 3 divided by 2 to the 5th power. It's the same thing as equal to 3 to the 5th times 2 to the 5th. So all that really happened was we gave each part on the inside of the parentheses this exponent on the outside. So each part gained that exponent. So another example, following along with the previous one, let's say I had 6 divided by 4, and I take that to the 3rd power. It's the same thing as 6 cubed divided by 4 cubed. Okay? So this was just kind of a review of some of these basic properties. Okay? We'll go over more of these, and we'll see these kind of as we go along in this lesson and in future lessons. Now, looking at kind of the new thing that we're going to be talking about today, okay, are rational exponents. So now, before we were working with exponents that were just nice numbers like 2, 3, 5, 6, right? Just regular integers. But now what we're going to be looking at is we're going to be looking at some rational exponents. So we're going to be looking at exponents that are fractional powers. Okay. So, kind of definition here, kind of looking at our base example. So let's say I have some number a, okay, and let a just be, say, an integer or a variable of some sort. Okay. If we take that to a fractional power, okay, what's going to happen is we're essentially going to rewrite it in this way. So in this form here, this is exponential form. Okay, like an exponent, it has an exponent, exponential. When it's in this form here, this is a rational form. It's now got that kind of that root onto it. It's rational. Okay, so we're going to come back to this bottom half. Okay, and we'll come back to this kind of in general here. We're going to move on to this first example because it's a little bit easier to see it with some actual numbers. So I have 5 to the 1/2 power. I want to write this expression in radical form. Okay, so currently it's in that exponential form like this, right? We have a to the m divided by n power. So 5 to the 1 divided by 2 power. So what we're going to do is, it might just be easier for you if you can label your m and your n value. So figure out which one is your m, which one is your n. Okay, so remember, the m is the one that's always on top. It's the numerator, right? In this case, it's 1. So we can say that m is equal to 1, n is equal to 2. Okay. Now what we're going to do is we're going to rewrite this. Okay, so it's going to be rewritten into the form of the n root of a, and we take that entire quantity to the m power. Okay, so if we're rewriting this, okay, our a is going to be the number that was originally there, right? The original base number. In this case, our base number was 5. So underneath that root, we'll have a 5. Okay, our n was 2, So we can write a 2 here to show that it's a root of 2, or we could just leave it blank because just that root symbol itself will show us that it's 2. And we take the whole thing to the power of m. In this case, the power is just 1. Now, you don't necessarily have to write the power of 1 because if we don't see it, we presume it's to the power of 1, but we can also just write it here to show that it's power of 1. Okay, so this is rewritten now in radical form. Let's try another example here, right, where our numerator wasn't 1. Okay, so we've got 3 to the 5a's. And if it helps you to write it out as your a as well, you can write a. So our a is 3, our m is our top number, which is 5, and our n is our bottom number, our denominator, which is 8. Okay, we're going to rewrite this in the form of the n root of a, taking the whole quantity to the power of m. Okay, so if I rewrite that, plugging in my numbers for each the n, a, and the m, we get the 8th root of a, which is 3, and we take the entire quantity to the 5th power. And that's it. That's where we're going to leave that one. Okay. So for these first ones, when we're just writing them in new forms, that's all we're going to be doing. Okay. So let's look at the next one. So we're going to start in start in the radical form, go back to the exponential form. Okay. Now it doesn't hurt to write out your a value, your m value, and your n value again. So our a value is 6. It's always that number underneath that radical. Our n value is the number right there next to the root symbol, so that's going to be 3. If we don't see a number there, it just means that the root is 2, right, a square root. Okay. Now, in this example, right, there's no parentheses around the entire number, right? We don't see it to a certain power. So if I don't see, they didn't give me the whole thing to a power, right, it's really the same thing as to the power of 1. Right? They don't show it, it's to the power of 1. So m is equal to 1. Now, we're going to rewrite this using the form, right, the original form here. So a to the m divided by n power. We just plug in the numbers that we found. So, we take 6 to the 1/3 power, and that is our answer. Let's try the next one. So, our a value for number 4 is going to be 8. M value is 5, so the number on the outside is your m, and the number on the root is your n, so the n is 9. So a is 5, a is 8, m is 5, n is 9. Okay, the form that we're looking for, right, is going to be the a to the m divided by n power. So that's going to be equal to the 8 divided by 8 to the 5/9 power. And that is our answer. Now we're going to get into kind of some two different examples here. Okay, a couple new different things. So the first one here is we're looking at this one, number 5. So we have 2x to the negative 3/5 power. So two things that are different about this problem are we've got two numbers on the inside of the parentheses, and we've got a negative power, okay? So don't get too alarmed with this, okay, because it's going to be very similar to the previous examples. Now remember, if we have a negative power, right, that negative exponent property tells us if it's not a fraction, it's going to become a fraction. So if it's on the top, we send it to the bottom. If it's already on the bottom, it goes to the top. So since this isn't already a fraction, we can really rewrite this as 1 over 2x to the positive 3/5 power, okay? And now we can just solve it like the other problems that we did, except it's just going to be in the denominator of a fraction. So, looking at this, right, we can write our a value, which is 2x, our m value, which is 3, and our n value, which is 5. So now this is going to be in the form of 1 over the quantity of, we got n root a to the m power, okay? And we also had that in our previous notes there. We kind of like glossed over a little bit, but this is also written there that we can see it, okay? So looking at this, we can replace all of our parts. So we get 1 over the 5th root of 2x, the entire thing to the 3rd power, the n. Okay, let's try another example. So we have 4x to the 2/7 power. In this one, we don't have a negative, so we can just go straight into it, right? So this is going to be in the form of the n root of a to the m power. Our a is 4x, our m is 2, and our n is 7. Replacing all of the letters here, the variables, with the actual numbers that we found, we get the 7th root of 4x, and the entire thing to the 2nd power. Okay, so we rewrote each of those into radical form, given the expression. Now we're going to kind of work backwards again. So just like 3 and 4, we start with the expression in radical form, and we want to go into exponential form. So we write out the value of our a, the value of our, not b, m, and our value of n. So a is the number underneath the radical, so x. M is the number on the outside, so 7. And n is the number right there next to the root, 3. This is going to be in the form of a to the m divided by n, so it's equal to x to the 7/3 power. Okay. Last one on here. Right, we're looking at this here. Our a value is going to be our 4x. Our m, we'll call it 3. And our n, since we don't see it, it's going to be a 2. Now, biggest mistake that you're going to make on this one, right? So we're looking at our form, right? Our form is a to the m divided by n, right? We're going to plug our parts in. We get our 4x to the 3/2 power. Now here's where the mistake comes in, right? So if we notice the original problem, right, it's a fraction. We started off with a fraction, okay? So this whole thing here, right, this doesn't quite match up. So what we're going to have to do is we're going to have to add a negative here. So to go from the fraction, right, to take it back to just the regular integer kind of situation we got going on, we have to add that negative. So that way it kind of will then, when we're going through it, if we were to convert it back to radical form, it would actually go into that bottom of that fraction. So we add the negative if we see it was originally a fraction. Okay. These last 4 examples here are just slightly different. Okay. What we're going to do is we're going to take it from the exponential form that it's in, turn it into radical form, and then simplify it from there. Okay. So let's start with this: 25 to the 1/2 power. Okay. Our a is 25, our m is 1, our n is 2. So I know using the form of n root a to the m power, this is going to be the same thing as the square root of 25 to the power of 1. So the square root of 25 is 5. 5 to the power of 1 is just 5. Okay, pretty simple for that one. Let's look at 10. So we have the 64x to the 18th to the 1/6 power. So first step is going to write that a is equal to 64, m is equal to 1, n is equal to 64x to the 18th. Sorry, I messed that part up there. Missed that. So now looking at our form, right, our form is going to be the n root of a to the m power. So that's going to be equal to the 6th root of 64x to the 18th. And we take that whole thing to the power of 1. Now, we can do the 6th root, right, of 64. So in order to figure out what the 6th root of 64 is, we can either do that on a calculator, or we can use, right, this kind of nice table to help us out. So we're starting off with powers. So n is 64, right? So the power of the table is 6, right? The 6th root. So we look at the 6, we go down until we find the 64. So we find it here. So if we go over, we can see that it's going to be a 6. So 2 to the 6th power is 64. So the 6th root of 64 is going to be just 2. Now the 6th root of x to the 18th, what's going to happen here with kind of these just exponents on a variable is essentially we're just going to divide 18 by 6. So if I take 18 divided by 6, I'm going to get x to the 3rd. And really we have this whole thing to the power of 1, but that's just going to make it stay 2x to the 3rd, because the power of 1 doesn't really do anything for us. Okay, so 2x to the 3rd would be our final answer. Now let's look at 49 to the 3/2 power. Okay, so our a is 49, our m is 3, and our n is 2. From here, right, replacing all the parts in there, we're going to get the square root of 49 and this entire thing to the power of 3. So the square root of 49 is 7. So then we got 7 cubed, which is the same thing as 343. Okay, and you can use the power chart table to help you out with that, right? 7 to the 1, 2, 3, 343. The last one is x to the 9th to the 1/3 power. Okay, our a is x to the 9th, our m is 1, our n is 3. So really this is going to be the cube root of x to the 9th. Okay, 9 divided by 3 is just 3, so this is really just going to be equal to x to the 3rd. Okay, that's it that we have for this video. If you have questions, you can leave comments in the video here below, and I will try to get back to you on any of those.